drawn or I've imported a picture of a wall. Can you see the framing, like the 2x4s or 2x6s or whatever they are? And this wall is supposed to be a nice square wall. In other words, all the angles are supposed to be 90-degree angles. And so what I thought I'd do is kind of give you a little bit of a head start on this. Let's see if you can figure out, how could you decide if this wall really is square or not? So it says Bob is constructing a wall for an addition to his house. He has measured the base length to be 16 feet and the height to be 10 feet. How long must the diagonal be if the wall is supposed to only have right angles? So does anybody know what the diagonal looks like? Okay, it would be the hypotenuse. We're starting to use some really good terms here.
So I just have a question.
Okay.
Do all the right angles have to be the same size?
All right angles are the same size.
No, like size. Like.
That's kind of the...
Like, I know they all have to be 90 degrees, but like, okay, so see, there's a little corner and that's 90 degrees, but so is like right there, and that's a bigger one.
Let me address that with you here real quick. Can I show everybody? Grace.
Sorry, I was talking to Cole because he was.
Can I make sure you guys all know what a diagonal is?
Yeah.
What is a diagonal? He said it's like the hypotenuse. It connects what?
The corners.
Yeah, two corners, that aren't together. Yeah, so maybe you could think of the diagonal as going from here to there. And Cole said the word hypotenuse, which is pretty important. So while I talked to Grace about her like relative right angle sizes, see if you guys can figure this out. And if you can't figure it out, that's fine. I'll kind of help you through it if you struggle at all. But take a minute, see if you can figure out what to do, and I'll check. See how you did. See if you follow with me. If I say something that doesn't make sense, just let me know. So here we go. If this wall is supposed to have right angles, then shouldn't I be able to use kind of that universal symbol for a right angle? Say right there. You guys know the right angle is like a little box, like a little part of a box. I should be able to look at this and say, hey, that angle down there should be a right angle. They should all be right angles, right? I'm going to go ahead and label the rest of my picture. This should be 16, and this should be 10. Cole was really quick. He said, hey, maybe it's the hypotenuse that we should be thinking about. And he's right. He's definitely right. Isn't the blue line the hypotenuse? Like if I look at this right here as a triangle, wouldn't the blue line be the hypotenuse? Okay, so Cole's idea I think is quite good. And so the real big leap here, and this is the part that I don't know exactly where your background is and what you've learned in the past. The big leap is, what is one of the main rules that applies to right triangles? Pythagorean theorem. That has to do with the lengths of the sides. That's exactly right. So what I'm going to do is I'm going to label this side here with a D. D standing for the length of the diagonal. You could label it with a C if you want. I know that that's customary, but you can label it with whatever you want. I'm going with D for diagonal. So here's what I could do. Apply the Pythagorean theorem to this, as you guys suggested. I would say 16 squared plus 10 squared is equal to D squared. Notice notice the hypotenuse, as Cole mentioned, is the longer side. It's the one by itself in the equation. Question, Grace?
Is the reason it's squared because you're doing both sides at once, not just like...
So this is the part where I'm not sure about all of your guys' backgrounds. The Pythagorean theorem is, and we'll come back around to this at the end of our class. Pythagorean theorem is a squared plus b squared is equal to c squared. It's the relationship between the lengths of the sides of a right triangle. It doesn't apply to any other kind of triangle, just a right triangle.
Oh, yeah, I knew that.
So they're all squared. They're all squared. Okay, so you do a little arithmetic here. 16 squared is 256. 10 squared is 100. That's equal to d squared. Remember, we're trying to figure out what the diagonal is. I'm going to keep simplifying here. This is 356 is equal to d squared. And here's where I get to a point where, again, I don't know all of your backgrounds. If we're trying to get the d by itself, but d is being squared, do you guys know, how do you undo the squared? Like, how do you get rid of the squared? Square root. That's right. So this is going to be one of our big learning objectives for today, is what do we do with square roots? Like, what is a square root? So I'm going to square root both sides of this. So on the right side, the square root undoes the squared, and I'm simply left with d. And on the left side, I've got this square root of 356, and I noticed a lot of you guys that got to this point used the calculator. What was that number you came up with? 18 point something? Okay, I think 18.8. 18.8 feet. So, the amazing thing is this. I want you to think about this. the house that my parents and I built, medium, largish sort of house, not huge. But it was really important that the building be square. I want you to think about something else on a much larger scale for a second. I want you to think about this building. This building is way bigger than my parents' house. Way, way bigger. Yet this building is quite square. Have you ever thought about this? Maybe you haven't thought about it. When they poured the foundation for this building, all the foundation walls and everything, how do you think they figured out that the angle, like on this corner and that corner over there, how do you think they figured out that the angles were really square? And I'm talking about the foundation on the bottom of the building. How did they figure out that the concrete walls were actually right angles? Pythagorean theorem. And they didn't use like an economy-sized protractor. You know what I'm talking about? They didn't lay a protractor down on the ground and be like, all right angle. You know what they did?
They did not.
They used the Pythagorean theorem. They measured the length of one side of their forms, length of the other side of their forms, measured the diagonal, and they said, hey, the diagonal should be this much. Is it that much? Oh, no, it's not. We better adjust our forms a little bit. We better move this over and move that over. Now let's remeasure the diagonal. Hey, look, it's a right angle. Whoo, right? Can you imagine how bad it would be if you built a building this huge, or maybe one of the buildings downtown Denver, and you were even off by like 1 degree? What if it was an 89-degree angle versus a 90-degree angle? If you're talking about a wall that's, 150 feet long, it's going to be off by a lot by the time you get to the end of that 150 feet. You want to know the way they do it? They use the Pythagorean theorem. Okay, now, building this size, they might even use GPS to help them get the length of the sides. But you know what they're going to use with the length of those sides? The Pythagorean theorem. Every time. Okay? This is a highly applicable thing, something that we all hope that they did right with this building and your house. Ashlyn? No? Oh, I thought your hand was up. Sorry. Okay, so there's a couple of things in here that I want to bring out that we're going to be looking at here today. We're going to be talking about what are square roots, what are the parts of square roots, how do they work, what are they all about, and we're going to be looking at applications like this with the Pythagorean theorem. Simple enough?
Yep.
Okay, so we're going to move through this fairly quickly today, and we'll get on to finishing up and looking at your test from last time. So let's go through some terminology here really quick. I think this will hopefully make sense from what we just talked about. A square root is the inverse operation of what? Squaring, yes. So if you square something, if you take something to the second power, then the way that you undo the second power is to do a square root. So let's take a look here at this next one. I think you probably all know the answer to this one, but let's think about what this really means. What do you think square root of 25 really means?
5.
That's the answer, yes, but what do you think it really is asking you?
Numbers that are the same.
What times what is 25? Okay, now that's potentially a confusing way to think about it, but
Itself.
what times itself is 25 for sure. So you could ask yourself that question. You could say, all right, what times itself or what times what is 25? What times itself, I like that one, is 25. And of course, the answer to that question is 5. Can you guys think of any other numbers that might multiply times itself to be 25?
No.
There are.
Wouldn't it be 5 squared? Because
Hold on. I'm asking a different question. I'll get yours in a second. There is another set of numbers that multiply to be 25. There's another pair of the same numbers. So 5 times 5. What about that? What about negative 5 times negative 5? Okay, equals 25 still, right? So when you see this notation right here, square root of 25, it's only referring to what's called the principal or the positive square roots or square root of a number. And so we would say, if we just see the square root of 25, we're going to say that equals 5. We only want the positive version. Okay?
wait, what do you mean? Then how would you know if you're trying to get the negative version?
There will be a negative out front. I'll show you an
So
example in a
only
second.
give one answer?
Yeah, if it just says square root of 25, you just say the answer is 5.
Okay.
Okay, some terminology here. The funny little check mark looking symbol there, which we know means square root. Actually, in general, the name of it starts with the letter R. Does anybody know what it is? What do you think? It's radical, that's right. So this funny little check mark thing that we always call a square root is called a radical. You can actually have different roots other than a square root, and that's why we generally will call it a radical. Does anybody by any chance know what the number inside the radical is?
The base.
No?
The number.
The square.
Also starts with an R.
The rational
I learned this last year.
Actually starts with rad.
The radicate.
Oh, okay. You got the next part, radic.
The radico.
Oh, man.
Radical with an L.
Radicand.
Radicand. There you go. So the radical is this little check mark thing. Radicand is the expression on the inside. So you might hear me refer to the radical, blah, 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 or what about the radicand, so on and so forth. Just want to make sure you know what those terms are. Okay. The next little piece here is, I think, something that would be useful for you to know, and I'm sure that a lot of you guys already know some of these. I'd be willing to bet that you guys all know those first two columns. I'm guessing that just about everybody knows those too. Once you get above 10, that's where we start to get a little shaky. 12.
I know the 16. Or no, I know the. Yeah, I don't know any.
So, do you memorize those or not? That's somewhat up to you. I find that to be useful as far as being quick. I think if you have those sorts of things memorized, I think in a quiz or a test scenario, you're like, oh yeah, sure, square root of 324 is 18. I think that could make you very fast versus having to turn to a calculator or do it out by hand on your paper. But I would say that these sorts of things would be optional for you. So there you go. So check those out. We're going to move on quickly here to our next activity, and it's this. So what I want you guys to do, based on, you've got to flip back, that's fine. I want you guys to not use a calculator. Do not use a calculator on numbers 1 and 2. I want you guys to try to evaluate these. Evaluate the square root of 121 and the negative square root of 16/9. Do not use a calculator here. Try to do this without. All right, so for number 1, did you guys get 11?
Yes.
Number 2, it should be negative 4/3. 4 times 4 is 16, 3 times 3 is 9. Hence the 4/3 for the square root. Do you all have any questions about that? Okay, grab your calculators, please. Grab your calculators out and let's talk about the next little section. It's right here. If the radicand is not a perfect square, the square root is what we call irrational. Calculator can be used to approximate the square root. So if you guys would, see if you can calculate numbers 3 and 4 using your calculator. Make sure you know where the square root button is and all that good stuff. I can help you with that if you need to. Sir. Yeah. Sure can. Uh-huh. Okay, so the first one was the negative of, the opposite of square root of 11. So if you guys have the TI, here's the button pushes would be negative. And then square root is right here, right above the squared. You see that button that just turned red? Square root is right above that. So negative square root of 11. You just put your 11 in there. If you got the TI-84 with this, I think the notation is pretty straightforward. It's just like you would write it. So once you get that in there, you hit enter. And I came up with that, negative, bless you, 3.31662479. Make sense? Good. I just want to make sure you know how to use the calculator. Any questions? Yeah, Lana. see how my square root of negative is outside? You put yours inside, and this makes it giant.
So you said it's like a negative, right? Wait, why did you get it? So what do you
No, I just did it all. So
Oh, your square root is right over your squared, actually.
Yeah, so I do negative.
So you want a square root. Why are you doing with carrot? Oh, I see what you're doing. The square root is right here, so you need to set it as a square. Getting to your second. See how yours is different? You did square root negative 11, and you did negative square root 11.
Oh yeah, high end.
Mr. Anderson,
Yeah.
so I can't find the square root button.
Because there's not a living human inside.
Hey, guys, something came up really interesting. I noticed. Listen up, please. I noticed that as I walked around, and maybe folks had questions. Maybe you had the same question. I noticed that some folks did something like this. Do you see how the expression above and the expression below are very different, right? One of them, the negative is on the outside of the radical. The other one is on the inside. These are very different, and they are not equivalent at all. As a matter of fact, if you did that second one, how did it work out? Not very well. You get this error of a non-real answer. Yeah. And so you want to be really careful that you actually keep the negative where it goes, and I think you should be okay. So for that second example, was it square root of 7/5?
Yes.
So you'd go square root, and I think I'd write it as 7 divided by 5, something like that. You hit enter. Here's what that answer should be for that one, 1.183, ... Okay, you guys okay with the calculator piece? All right, fair enough. Question, yeah.
So are we allowed to just round the numbers?
So, hey, listen, Kendall asked a really good question. Like on a quiz or a test, I'll be specific. I'm going to say round to the nearest hundredth, blah, blah, blah. So, there's no any one standard in a non-science class. In science class, you'll learn about a thing called significant figures. Maybe you've already done that. In our class, I'll specify. I'll say round to the nearest 3 decimals or something like that.
Okay.
Yeah. And your website do the same thing.
Okay.
All right. Any other follow-up questions on that? Okay. Kendall, I would say if in doubt, put them all.
Okay.
Yeah, if in doubt. Okay, so this kind of goes to the thing we were actually just talking about. Which of the following is a real number? And maybe what you could do is use your calculator to help you do this. If you're unsure of how to proceed, maybe use your calculator with A, B, and C and see what your calculator tells you. Just enter those in there and see what it says. That might give you an answer. We can talk about the pattern here in a second. Take a look at A, B, and C. A, real or not?
Not real.
Not real. A is not real. B, real or not?
Real.
It is real. And C, real or not? Not real. So can anyone identify the pattern within the not reals? What's the issue? Yes. It's the negative inside the radical right there. Okay. So can we talk about why that's such an issue? Let's take a second and do this. If I just took this radical over here, if I had square root of negative 4, just as that is, remember a square root is essentially asking yourself what number times itself is the radicand. So what number times itself is negative 4? This is where we run into the issue, right? Because what might be someone's initial kind of answer, just real quick answer? They might say 2, or they might say negative 2. So they say, all right, I think this is 2. But if you think about it, 2 times 2 is not negative 4. And then the next one would be, hey, no, I think it's negative 2. But then keep in mind that would be negative 2 times negative 2, which is not negative 4, right? And so since neither of those is equal to negative 4, this didn't work, this didn't work, this didn't get us where we wanted to be. We have to arrive at the conclusion that the square root of negative 4 is not real. Okay? In Algebra 2, you learn what to do with that. You'll learn this imaginary stuff, imaginary numbers stuff, and it's really not that hard to deal with. You just haven't done it yet, so you just wait till Algebra 2 and you should be fine. Okay? So what I thought I'd do is finish off our time here with numbers 6 through 8, and I thought I would do, why don't I do number 7 with you, and I'll leave you guys to do 6 and 8. We'll check your answers in the end. So remember that a square root is simply asking yourself what times itself is the radicand. So when I look at number 7 and I see that it's the square root of x to the 6th, what this is really asking is what times itself is x to the 6th. So what times itself is x to the 6th? Let's think this over. If I did x squared times x squared, what do I get? X to the 4th. So that doesn't work. If I did x times x, I get x squared. So that didn't work. What do you think might work? X to the 3rd times x to the 3rd. Because x to the 3rd times x to the 3rd, you add your exponents and you get? So I would say that the answer to this one is x to the 3rd, because x to the 3rd times x to the 3rd is x to the 6th, right? If you're multiplying your bases, you add your exponents. So let's see if you guys can handle number 6 and 8 using kind of the same sort of logic, and we'll check your answers in a second. Ready to go. Let's look this over. Let's see if you notice any patterns that might be helpful for you. So for number 6, did you guys get a to the 1st or just a?
Yes.
Okay, so that is correct. You could always check this by taking your answer there and multiplying by itself. So if you did a to the 1st times a to the 1st, you should get a squared. And because this matches with this, I would say that checks, right? So the answer for number 6 should be a. Down here for number 8, what times what is 49? What times itself is 49? 7, yeah. So this is going to be 7, and then r to the something. And this is maybe where you do a little thinking. You think to yourself, all right, what times itself is r to the 16? R to the 8, actually, yeah. So the most common wrong answer was 7r to the 4th. If I multiply 7r to the 4th times itself, I definitely do get 49. But when you are multiplying bases, what do you do with your exponents? You add them. 4 plus 4 is 8. So you'd get r to the 8th, meaning that this was not correct. If you think about this one, you'd get 8 plus 8, which would be 16. Grace, you with us?
Yes.
Awesome. And so 7r to the 8 would be the correct answer there. Saw a lot of good answers. Are you guys all okay with the r to the 8 versus r to the 4? That was kind of the one thing that we maybe should talk about there. Okay. Do you guys have any follow-up questions of any kind? Okay. So here's what I want to do. We've got that Pythagorean theorem question left. I think I want to leave that possibly as a warm-up for tomorrow. What I want to do right now is I want to hand back your Chapter 7 quests and give you a chance to look those over and ask questions. So let's clear your desks off. Thank you. We'll get to that.